Hi everyone, my name is Vaishnavi. Today I'm presenting my database concurrency control simulator project. And here is the objective and description of the project. This project focuses on solving most of the critical challenges in distributing systems, managing shared resources like inventory when multiple users access the simultaneously. Now I will show you the README file. The goal is to build a REST API that simulates and e-commerce in inventory system. It mainly focuses on comparing two fundamental concurrency control strategies: pessimistic locking and optimistic locking. It ensuring data integrity while maintaining high performance. Here is the complete readme how to get started and set up the environment, launch services and API documentations, and end-to-end testing processes. Now the tech stack I use it are the tech stack used in this project is the list are backend I use Node.js with Express, and for database PostgreSQL 15, and for containerization Docker and Docker Compose. Here Docker is used for containerization and testing shell scripts for concurrent loading testing. And Docker Compose file, it stores us the services. It stores many services which are needed for this task. And now problem solved and real world problems use case. The problems are race conditions. If two users buy the last item for example, two users buy the last item at the exact same millisecond without locking, the system might accidentally let both the orders through, leading the negative stock. The use cases of flash sales. Thousands of users buying the same product, like from Amazon or Flipkart. And another example is ticket booking. Ensuring a seat isn't booked twice, for like Book My Show. Uh, and and another example is banking, preventing double spending of the same balance. And the architecture and the flow of this project is the architecture and flow of this project is high level flow. When the first step is client sends a post request to API, and then to orders. An app initiates a database transaction. App applies a lock, pessimistic lock, or reads a version. Here we use optimistic lock. And later app updates stock and records the order. And finally, transaction commits or roll back based on the success. If the transaction is success, it commits. If the transaction is failed, then it will be rollback. This is the main core of the task. Now, system mechanisms, and by this approach, I use it is for pessimistic pessimistic logging proactively locks the row. I'm working on this. Nobody else touch it. Best for high contamination scenarios where conflicts are very likely. And whereas optimistic locking checks for conflicts at the end. Go ahead and try. If someone changed it while you are working, try again. It is best for low to medium contamination. And the reasoning is I implemented both to show the trade offs. Pessimistic is Pessimistic is simpler but can cause bottlenecks. Optimistic is faster but requires retry logic. And limitations and the improvements required for this project is the limitations are current pessimistic logs waits indefinitely, which could cause timeouts, and the improvements needed are implement select asterisk for update skip log for better throughput in some scenarios, and use a proper migration tool for better schema management. And the future scope is integrating Redis as a distributed log manager to handle concurrency across multiple services instances. Now we're gonna test this project end-to-end testing sequences. First, phase one of this testing is preparation. We check the health check and reset the system. Reset the system. Before that, Dockers minus compose space up. It is used to start the container. Here, as we done it, the container is started, and the Docker is started. Now we're gonna open Git bash to run the commands. Here is our Git bash. Now we are going to our and here are the list of commands I have to run. Okay, the first command is this to check the health of the project. Sorry. Here the output is status up. That means the container is started. The health of the task is good, and the second one is research system. Here, the output is product inventory reset successfully. It means the reset has been completed successfully. And the third one is verifying the initial state. This is the command that should be executed. Sorry. Verify initial state. It means to check the initial data that is stored in the database. Here ID1 name is super widget and the stock is 100 and the version is 1. And now we check the pessimistic order. Here, here the order is successful. It shows order ID and product ID and the quantity of the ordered and the stock remaining left. Here in the upper command, the stock is 100. Once the quantity ordered is for 10, the stock remaining has been decreased to 90. And now we are going for optimistic order. Sorry for the inconvenience. I have forgotten to keep the URL here. So the error erased. As it is optimistic order, we have to give here optimistic. Optimistic. Now copy this. Now the order ID is 2, product is 10, and again the quantity is 10. So here in the above, the 90 is the stock remaining. Now, as we taken a quantity and ordered more 10, so the stock remaining leftover is 80. So we ordered the stock within the limited. Here we know that 100 is the total stock. So we ordered 10. But now we can check for the out of stock. We know the stock remaining is 90. So now we can check. Sorry, the stock remaining is 80. So now we can check quantity of 500. Let us see the output. So 500 is out of stock. We only have 80 quantity. So it's saying that insufficient stock. Now let's view the status. Uh, Now let's view the order stats. So we are So now the total orders we done are three, and two we have two successful orders which are under 100, like 10 or one is 10 quantity and another one is 10 quantity. And the failed out of stock is one where we assign the quantity is 500. It is failed. So here is our total order stats. So this is the end of my project. Thank you.